Hello, my name is again Kalle Launiala. Welcome to watch this second part of the ball and SOS on Azure. This part 2 focuses on developer experience, getting hands-on experience and hands-on demos of how you actually can build the software on top of the platform and what architectural designs and constraints are applied. So first we get the developer getting started from scratch, starting from git clone, building and deploying to debug the solution. Then we, on the first demo, also present how we develop the HTML on front end in combination with back end, and kind of through the demos also deep dive into web and worker role responsibilities, and then more on focus on the architectural overview and deeper dive through Visual Studio and a few slides that cover the architecture. So first, for the developer setup. Get the sources and build consist basically you can get the whole project from the GitHub, then issuing the git update project command to get the git submodule content. And then building the solution in proper order would be to build the ADM solution first. That kind of builds up the automation modules, then run and debug the abstraction builder that runs the actual automation, which will output a series of source codes to the main solution. Then to the main solution, to the ball on Azure, build that one, and then to last bit of the deployment is to open the solution, the ball Azure configuration, that builds and deploys the actual workers and web roles. And basically, after that, we still need to feed the binaries to the accelerators. So there is one command to run that copies the build main solution build content to the blob storage so that the accelerators can start using it. Solution structure, once more, is divided on those three solutions. ADM drives the automation, main development happens on the Azure solution, and configuration solution is for managing the accelerators and publishing the accelerators to the roles so that then can be started up. Few words of developer settings. We require IIS, so that is Internet Information Services, or the IIS Express. Basically, to get the IIS Express in Visual Studio, it requires the real IIS to be set up in Windows 8. Otherwise, the HTTP handlers don't work properly. Also, worth of noting that the IIS Express port sharing is evil. So basically, it can create a virtual directory without introducing it on the kind of full-fledged application in IIS, but it means that if you share the port between different solutions, it might run the solution from the other directory, which means that debugging kind of gives you red dots that it's loaded, but the breakpoints never hit, and it's running the old version. Debug input parameters for the ball tool. Basically, there is a tool that provides the copying to the blob storage. You're supposed to give the full path to the account directory for the root of the templates and mind the storage keys, which are now used development storage, but of course when deploying to the production or real Azure, use your account keys and account names properly. And then for the accelerator config for worker role and web role, the current one are used for the developer emulator. Because of the sensitive key level information in those files, we don't distribute proper examples for cloud versions right now. They kind of are crafted from the current ones, but usually should be taken or should be stored outside the version control repositories. Then on the demo one series, which is longest one, that explains the whole development process, it always goes with the ADM style. So you modify XML models that are design level abstraction layer, information model and process model in this case, and we demonstrate how you get the status tracking and basically architect to developer guidance out of the box. Then we run the transformation and generators that actually do generate the documents and the source codes. Basically, this also from architect perspective means that you can maintain these things. You can craft your automation to suit your need, alter the code generation, alter any aspect. They are all open source and are actually quite structured to be modified. And then as the last step is you have to implement the manual code for the hooks that your automate generated or orchestration generated, which also means that you can take benefit of any commonly used libraries here, as your generators can target those as well. We target here only Azure SDK 1.8 right now, but there is no problem using libraries as with manual development. Then for the demo time. I'll go through the demo sequence here. The demo 1 is much broader now when we do this offline than what I held on the actual Tech Days presentation. It consists now the solution overview, ADM generation role, building and deployment to the Azure Dev Storage, but it also includes offline UI development and also modifying the ADM models, seeing the status tracking, seeing the documentation changes, implementing the hooks manually. Then demo 2 will be about brief explanation of HTTP handlers, showing how thin they are, few words about postback, few words about developer handler, which kind of serves part of the content from the file system and only the storage content from the data storage. Then demo 3 will be about blob storage usage for web content, few words about HTML templates to be rendered as HTML pages. That was actually the technology that we used on the early stage of the platform about last year's September, October. Then we started to move on jQuery side, refining of information models, taking the HTML designed or libraries in use, jQuery libraries in use, and then quite recently actually we concept tested Dust and Mustache.js in combination with the XML to JSON converter and realized that that's the way to go. So that's why we focus on the client-side rendering mostly as a preferred solution. On demo 4, we go for the queue usage and a real parallel execution of things. We cover up the queue messaging, queue envelope, that's also kind of an information object in the ball structures, and then task-specific context to show off that our workers are thread-wise parallel as well, taking advantage of completely owned cores that may have delays on blob I/O, which means that we want to run CPU operations on 3 in parallel to take advantage of the waiting for the blob I/O. The demo 5 will be about blob storage usage in a kind of advanced way. We properly introduce the information objects, their masters and collections, metadata, simply showing how this stuff is located in the blob storage, subscriptions, and atomic queues that can kind of have parallel workers but still take a log of certain larger area of processing, which will be in this case a complete security context that's being worked and processed only one at a time. Then on demo 6 we will connect the demo 1 stuff where we very briefly modified the operation and kind of made it not so clear how the operation is actually plugged in to the actual web front end. So here we go through the code that connects the actual web form post back to the logical operations. Currently it's a kind of manual switch, but we are working on a proper implementation of complete service layer migration integration point, which kind of allows us to expose any operation to be either web called or a mobile device called or another instance called. Okay, after the demo time, a few words about the architectures. So first let's dive a bit more of the information context part. reminding of this picture, we have separated the authentication of authorization. Authorization brings us always to certain security context. By default, we land on account context where our Hello World demo is all about, but basically we can also be part of the group context that's always completely independent and separate. And information flowing through these contexts needs kind of a semi-level integration. It's a traversing through controlled and most specifically authorized connection points. This is partially for the architect design decision, and right now we don't have a out-of-the-box solution of how it should be done, but the few skeletons are available. Again, reminding from other angle that we really have always collaboration groups that owns the information. It might be documents, it might be binary or media data, everything within the group falls with the control of same security context. And then there is completely public area where we can publish things that for people who are not necessarily part of the system. So, more details on information context. It's always an owner-specific authorization box. It also means that we can even fine-tune it to be more detailed. A domain-specific authorization is possible. That's where the specific apps or services, even when running in a certain owner box, can be constrained to only kind of deal with themselves and have controlled integration or information exchange with other applications and services. Basically, it's a code-wise, as demonstrated, served as a current active context kind of static global property. It also makes an intuitive spot to do changes and caching managed at this level. Also, the change subscriptions are launched at a context close. So basically, we can track down the changes. We don't fire the subscriptions until we are closing the context, and then we can publish all the subscriptions at the same time. The model is basically analogous to entity framework or any object relational mapper or web stack context, such as data context for or object context for AF or link to SQL, or HTTP context for a web stack, kind of request specific current context. We have HTTP context is given from the web request. When using the tasks, we use the unique task ID with the synchronized dictionary to log in, actually give a task specific context for the requests. Few words about the storage layer, about the owner content. Owner content is kind of content root folder in the blob storage in a way. Information object type is basically the base class for data. Then we support all kinds of other content, kind of in our way unstructured media, plain HTML. It's for us just a text or just a content. So it's supported as is. It's served from the web stack if the request is authorized. No questions asked. Metadata is relative to content. It's kind of information object of its own, but it's a completely relative to the actual content that it's referring to. And the reason that we needed to implement metadata this way is that while blob storage has its own metadata, it's capped at 8 kilobytes. And we actually run out of it even with plain subscription level metadata information. We have certain kind of special case for location so that we can have a directory metadata as well, where there is no object at all, but we can, for instance, track down the collection changes of the whole directory containing the actual typed object. And everything is a blob content, even the metadata. We evaluated and saw no benefit from table structures. Even the queue usage is limited. Blob access being authorization scoped also reaches with the design everywhere. The issues with the table structures is that they don't give much additional benefit, but only constraints. You can only put something like 4 megabytes per one table row, and even for the queue, same things apply with much stricter sense. You can have something like 48 kilobytes in one single queue message. And that's why we kind of implemented blob storage for the actual queue delivery when we need to deliver something bigger than that. So otherwise, of course, the queues and tables would be just as scalable and just as cheap to use as blob storage. So we wouldn't have a problem to pass large objects through the queue. But then these constraints actually make the design even more simple, because all the storage is now still on the security context, and the queue is just passing the tokens of where to render, in which context, and to where. Authentication layer is right now implemented with .NET OAuth library. We use that as a base to validate the OpenID, for instance, but we use our own custom cookie usage to be able to handle the web forms in a way that we know that it's compatible. We can also expire the key or reroll it. So, but it needs to kind of handcrafted approach to design. Currently, we self-store the IAS key, much like it's analogous to ASP.NET Machine key. It should be never published or even got from the blob storage outside. We can do the key expiration and per request payload possible, but these kind of come with the design aspect that if we want to support multiple browser instances on same session from the same user, we have to kind of design so that the cookie is persisting regardless of which browser session was requesting last time. Good point to note that authentication is not directly connected to authorization. So multiple authentication methods result to the same account, and still, of course, authentication method may affect the operative authorization. What I mean by this is that if we have an integrated system with a very strong authentication, such as bank number codes, and we are connecting the official system. Let's say that we only connected the official system that accepts these keys. We can still cross-integrate into information or authorize. We could have a system where we authorize the other end with the less strict authentication, such as OpenID provided by Windows Live ID or Google's Gmail. But of course, in the end, the system knows which authentication is being used, so it can effectively authorize certain kind of operations based on stronger authentication. Then a few words about the actual authorization layer. Every request is either completely public or anonymous or completely authorized. It means that every content that we serve in web content management wise, be it web styles, sheets, images, and so forth, if they come from the groups area, they are all authorized. It also kind of allows us to then use the content delivery network and all kinds of distribution mechanisms for completely identified public content. And we can go as sophisticated as identifying binary with the MD5 hash, and even serve the content delivery network linked binaries that might be authorized content, but if some other party is already publishing the content, we can take advantage of that one. It's for shared videos and all that stuff. It comes quite handy. It also frees our group from cost-wise storing the information or huge videos that are being published by other parties as well. We can share the cost among all who want to have the access to that information. Authorization is done in denormalized form, which means that when given the request path and given the authentication cookie in the request, we can get the authorization token with one request. For the account, we actually need only the cookie to perform the request. But nonetheless, it's always a one request, or we could cache it. But at most, it's one extra blob storage request for every request. Account ID is obtained from the cookie because we store it there through the encryption. We could have a one denormalized lookup there, but right now we store it in a way that we can retrieve it from the authentication cookie. And we could cache the lookups, but then we have to take into account that our web farm consists probably at larger deployments of tens of servers, which kind of might nullify the effect of the cache, especially if the expiration time need to be low enough and the amount of requests still too diverse for the users. So depends of the settings. Caching sound okay. Well, on certain occasions we should definitely cache them. Okay, then a few words about the events for changes. Active triggers and passive monitoring. So how do we track the master data changes? Active tracking, we have subscriptions, which means that we have source to target subscription types for different types. It means that we have web content that's being rendered if its sources change. This is mostly when we do background rendering of templates. Doesn't apply much with the Dust.js technology. Then master collections subscribe to their master object directory. So any addition, modification, or deletion polls a subscriber to update the master collection. And again, objects that use some other master within their structure also subscribe to master object changes. So every change on such an object, if it goes to the area of master object, is actually the change is made to the master first, then verified from its e tag that the consistency that we had up-to-date information of that object, and then it can be changed on that very object. But they also subscribe to other parties changing the master objects. Update flow is handled kind of in atomic single processor. So what we described on the first part of the session, in the end of the master information management, it means that we do it in a directed acyclic graph that's been generated from the subscriptions. So we kind of follow the subscription chain, that if we go and modify this object, it has subscribers. Where does the chain then populate to? And it's dictionary-based information object update evaluation. So we kind of read a lot of subscriptions from the blob storages, but then we cache them during the processing. And then when we render the human readable content in a way, in a reports, web pages, kind of end of the chain content, where the actual information doesn't anymore change, but we just need different representations of the information. That's what we do in parallel. So at that stage we populate, send every single request to the queue, and let queue processing of workers take care of every single request. So it kind of scales with the once it gets the order by evaluation out of the way. Technically, subscriptions are implemented, they are stored in a metadata. So it's a kind of information object or directory object collection monitoring. Blob directory for atomic operations is used in a way that we take a listing of a blob with certain prefix, and then we do a kind of very simple file system kind of way. We insert a log file if there is none. If there is one, we know that somebody else is logging that directory right now, but if not, we take the log and start processing. And new items can be added while atomic operation is processing. New items on this way, subscriptions change. Every change enter a new item that something is changed to this directory. And we don't try to get these new items in the processing on the fly. We rather ignore them completely and only delete the files that we processed, which means that right after we've finished processing, if there are new items that appear during the processing, immediately next worker we spot the new items, issue another log file, and start processing of the changes. Therefore, we can control the evaluation order, and we kind of guarantee that when there are no new files and we have a lock, nothing is changed in the system. So we can kind of rely that we have a consistent state system at that moment. Then for the parallel operation, we use the standard Azure queue. Processing is still context bound, and this is for when evaluation order does not matter, when we can completely parallelize the thing, or even start atomic operation while the parallelized operation is still ongoing. Then we've identified that passive tracking is also required. Right now there is no out-of-the-box support for that. We haven't implemented it. Active tracking kind of creates costs outside of our control, which means that we cannot have subscribers of the chains that start to traverse between different groups, because that link of groups who is actually in the end interested in our published information could grow really fast to huge amount of network. And that's why we need a kind of polling and monitoring technology in a kind of traditional fashion. The callee polls periodically for changes, and it can use the MD5 timestamp to figure out whether the thing is changed. Of course, the engines should support this kind of behavior, but it needs to be distinct that the subscriptions are proactive. They start to happen immediately after the change. And then the monitoring is a passive kind of polled when needed kind of thing. And the thing is that the legacy applications can take benefit of monitoring approach immediately, because they can simply call a certain web service where they receive the up-to-date status info, and then they know if they should retrieve more information or not. Okay, then coming to the wrap-up and some food for thought. Few words about metrics, overhead and searches. Because we control every operation on the platform, we can have very exact monitoring of resource usage divided per context. Of course, we could go even finer than that to application level basis, but even coming to the context starts to introduce pretty new kind of possibilities for charging resource usage. We can kind of calculate the CPU, storage and network usage and have completely transparent cost-based billing derived from Azure billing. Not only this, but when we start to have some kind of visualization graphs, we are working with some cooperative parties to work for these visualizations while we are busy building the actual core. The metrics are completely analogous and basically immediately applicable to real-world work and real-world processes. So if we take into the example of real-world pizza delivery, there we don't have, of course, CPU, storage, and network. We have different terms for work, for resources, and for whatever parts are in that process. But basically, they all gather costs from somewhere, and then the additional value for the pizza business gets its premium to the final price. This allows pretty transparent ERP systems to be simulated and costs calculated throughout the whole subcontractor chain. Then another word for such a processing overhead of relevant processing, any. Basically, execution can be tailored through generators and implementation. It means that if there is a way for manually to do it in a more clever fashion, there is no reason why the ADM automation wouldn't and shouldn't be bent to that way. It means that when we look at the actual pure information and pure processing, we can get really close to kind of mathematical optimal amount of CPU cycles to get the job done if we want, and we are already, that would be kind of over optimizing things. We are pretty close to quite good performance already because our orchestration is just native method call sequence right now. Caching the blob storage fetches would improve the performance greatly, and that's the option that we can take. We can also kind of, in a more fine-grained solutions, evaluate the operation structures and see, kind of compiler optimization at higher level. But for that, I'll I'll be happy to leave it for some research groups, hobby or a focus area. Searches. You didn't see any searches on this demo. Why? Because they are kind of on priority backlog. Right now, we can easily do authorization context specific indexing through the traditional SQL Server, even in the SQL Azure. We have on a priority backlog to port in the Lucene.net and Azure directory, which would allow us to use Lucene indexing on these blob storages. And that would kind of free us from scalability and context issues. We can deal with those with SQL as well, but we kind of have to introduce more databases on the fly, and it gets a bit more complicated than we need to do when we can completely control the indexing. Then legacy migration with reference architecture. ADM was designed to solve this actually initially, to control the reference architectures. We haven't yet plugged it in, but on my last year's ADM sessions we have actually complete demos of building from scratch the ADM with the Go generators. And then on the final example of that would be service layer abstraction, which is pretty straightforward. It has a Windows Communication Foundation client and a server, but more importantly, it introduces a way to describe the service layer in an abstract way. And simply plugging that ADM module in would open up the whole legacy migration stack on the ball. So it's just few steps away, but we have been busy now gathering the pilot usages and see for the real usages for those. Because some of the Internet of Things and embedded companies, they don't want the HTTP stack at all. So we can wait for those to start implementing and then directly make a migration ADM automation that takes care of those parts as well. Okay, for the material available, we have the tech blog, which is possibly the way you entered into this presentation anyway. Videos and slides of these demo video sessions are all available in our tech blog demo videos area. More about ADM, I link in the blog post of Tech Days 2013 of the ball presentation, where you can dig more information about the ADM. And then you can contact us directly through my email, kalle.launiala@citrus.fi, or through, for instance, LinkedIn groups. We would like to hear from you if you are starting to use the platform. Occasionally, it's just a handful, but it's always a pity to hear that somebody used it for something, bumped into issues, and they solved some issues, but then they are kind of have been unaware of the progress of some other partially siloed development where we have been involved, but it's been 2 development stages, so that we couldn't have published much on the blog to apply in a generic fashion to everybody. That would be all. Thanks for coming in this virtual event, and for any questions, don't hesitate to contact us. Thanks for listening.